In this video, I'm going to show you how to test what the operating hydraulic pressure is of your mini excavator. Not only that, but I'm going to show you how to make adjustments to your hydraulic pressure if adjustments need to be made. Now stick with me to the end of this video because I'm going to use my own excavator and I'm going to make the hydraulic pressure climb all the way around 29 to 3000 psi. And I also test it where I take it down to 18 to 1900 psi. Now that's the high and the low. In between there's some other points that I adjust it to, but I take the excavator through function test where I'm digging through the dirt. That way you and I can both see how does the machine respond to both high and low pressures. And the ultimate question that I want to know, and probably what you want to know, is what is the optimum PSI for these machines? Now, before we can actually test this, we need to know what the baseline is. So I've got an AGT WH12R mini excavator. I've referenced that manual that came with my machine, and wouldn't you know it, nowhere in there does it show anything about hydraulic pressures. So we're going to turn to our friends Google and ChatGPT just to see what they say about what the operating hydraulic pressure should be for these machines. All right, let's start off with Google. What is the operating hydraulic pressure for an AGT 12 series mini excavator? Let's see what Google has to say. All right, looks like 2300 to 2320 PSI. It says, though users often find success adjusting them to 2500 to 2800 range for better performance. Okay, now let's see what ChatGPT has to say. Same question. She's thinking about it. She says, good question. It depends on which specific 12 series. But it says 2320 PSI. 2320. And there's, a variation of different models right here. All of them have 12 in there. All right, so I'm going to type in AGT WH12R. Okay, for an AGT WH12R, 2320 PSI. So it looks like 2,320 PSI is that optimum range for these 1-ton excavators, in particular my machine. So let's go out there and just confirm. Did the factory have it set at this? Is that what my machine is at? And then we're also going to test, like I said, how does this thing respond as we increase the pressure and lower the pressure? Let's get started. All right, so if you notice, I have the shroud from that valve body off, and of course the handles are off right here. I've got the parts in the seat. I may move those because of the vibration when I do this test, but I haven't disconnected anything, any of the hydraulic lines for the moving parts. I've got the bucket on the ground, boom is on the ground, blades on the ground. Hydraulic pressure has been relieved. I've manipulated all the handles to ensure that there's no hydraulic pressure remaining in any of those lines. And the reason why is because whenever you remove that shroud, it's inevitable you're going to be bumping these and moving them. You do not want to have this thing up in the air whenever you're doing that. Once that's off, you have access to this area right here. So I've got a hydraulic pressure test gauge. I didn't have one of these before, but I've got one now. This one came from Vevor. Now this Vevor brand hydraulic pressure test kit, I got it for a very specific reason. For one, it comes with multiple adapters, and the one that I was really after was the M14 1.5 thread. That was very important because that M14 1.5 thread is actually what's threaded into here. I don't know the official name for this, but I'm just going to call it a test port for this video. Now that M14 1.5 thread will also thread into this right here. If I wanted to test it with this auxiliary, I should be able to do that. The other reason I chose this was because it comes with this tubing right here, this line. And this is, I want to say it's a 5 or 6 foot line. I'm going to clean off this seat, get all the bolts and screws off of here. I think my thoughts are I'm going to sit in the seat, manipulate the controls, and I should, from here, I should be able to see the gauge. All right, so that's the bucket deadheaded. Looks like 2,300. And that's deadheaded, both directions. I'm gonna deadhead the boom. What I'm gonna do is I'm gonna use this 17 millimeter box end, and I'm going to crack this retainer nut right here. I've got the engine off, by the way, and I've already relieved all the pressure out of all these handles. But there's a lot of remaining thread, so I'm actually going to start by threading it in. I'm going to rotate to the right. Maybe, I don't know how much to go. Revolution and a half. That'll tell us, you know. So let's see what difference that makes. All right, so I'm going to deadhead the boom up. Yep. That may be too much. Let me do the bucket. I'm thinking that's too much. I'm going to ease the bucket out, try to anyway. Well, at any rate, I could see that that thing was flickering all the way over to around 3 grand. So I'm going to back it off. Let's see, we went in rotation and a half. So I am going to back it off half a turn. Let's see what that does. All right, start off with the bucket. It just keeps wanting to die. So I think what I'm going to do is I'm going to back it off a little bit more. All right, so that's 2,600. Do I have it zoomed in? All right, so that's deadheading 2,600 with the bucket. Let's try the boom, boom up. And it's not killing the engine. I'm going to oh so slightly. I'm talking quarter turn to the right. Maybe not even a quarter. Looks like 2,700. All right, I'll do the bucket. Got the 2700. Now, here's the ultimate test. Can I have the RPMs low and actually function this thing? So I'm going to get on it. No. I believe the only way to really know if 2700 is good is to just do a function test. So I'm at a place right now where I can use the machine. I've got my hydraulic gauge just actually taped right here. 2700 actually may be a little bit too high. I actually have to come back down. Let's find out. Hear that? Hear how it's wanting to die? PSI. Let's try that. Okay, I went completely the other way and now we're at 1900 PSI. Let's just see how it works. Still able to do 2 movements. It hasn't died on me yet. So I can tell a little bit of difference in power. Like before I could have pulled that through. But I gotta tell you, it is smoother. It's definitely smoother. So that's interesting. I don't know how much noise there was, so I'm just going to recap. We were at 2700 PSI. It was just a little bit, a little bit jerky, not crazy, but a little bit jerky. But the problem is the engine will die. But now that I've lowered it to 1900 PSI, is that what I said? 18 or 1900 PSI. Much smoother, the engine's not struggling. Has a little bit less power. So maybe if we can take it to, I don't know, 2100, maybe I'll take it to 2100 and try that, or maybe 2000. Okay, so I adjusted it to 2100 PSI. Shouldn't be a whole lot different than where we started and what we were just at. See, It's smoother. But normally I should be able to pull through that. But it is more enjoyable. And actually where we started at may have been optimum, 2350. There's probably a reason they set that way from the factory. Let's see, 2200, need to go to the right, quarter turn. Honestly, that's where we started, around 2300. This whole video, if that's where I end up. I changed positions and we're pretty much where we started, 2300 PSI. Just see what it does, I guess. On a route. I feel like that's optimal. And let's see here, let me deadhead it. 2300. Pretty much where we started. All right, guys, so I think this is a good spot to end this one. This one's strictly about adjusting the hydraulic pressure, not getting out this stump, which I think I'll do another video on. It'll be following this one. But so we saw how to do that. We saw what tools I used, and we also saw what the results are if we went up in pressure as we're approaching that 3000 PSI, or actually maybe just barely crossed it at one point. And then we went below our threshold, like what we started with, around 18 or 1900 PSI. Definitely a lot smoother, and I could pull the RPMs down. But ultimately, we actually ended up back at 2300 RPMs, which is kind of what we started with, maybe a smidge lower. And for this machine, it seems to be the sweet spot. That's not to suggest that that's the sweet spot for every machine. They're probably all a little bit different, but I think I'm going to keep this one around 2300. It seems to be a happy medium between the strength of the PSI to actually pull that dirt around, but not so much that it's killing the engine. Hope this video helps somebody out there, but that's going to do it for this one. Stick around for the next video because I'm going to keep getting that stump out. That's the stump that the LRT23 could not get out. It just couldn't get deep enough. That's the only reason why. But I think I'm going to keep going and remove that with the WH12R. That's going to do it for this one, guys. As always, thanks for watching.